Okay, so we're live. Switch to the desktop. Pretty good. Excellent. Right, so and almost always I'm a little behind, and I haven't put up yesterday's slides, but I promise you it's coming. I haven't even put up Friday's slides, and I still need to fix our video so that I cut out the bit where I played the Penguins clip because apparently that's copyright BBC, and I don't like free advertising, so we have to delete that. I have to delete that, but it is coming soon. It's coming before Friday because I intend to do nothing in this recess. That's coming, and that's not fair. I'll be working hard in this recess on this course, planning ahead. And in return, you must do a little something for me as well. During the recess, please read those pages. It's about a case study. It's the end of chapter 1. After the recess, we'll start with chapter 2. But it's the end of chapter 1. There's a case study which should firm up your knowledge. You should understand that. Yes. Oh, you're not writing to me. But you don't want to ask a question, do you? No. Right, so I'll put up this quote. Okay, didn't notice that. And these chairs are freaking me out. I'm just going to move a little. I don't know why they have extra chairs here. Maybe for a test, but there aren't any extra desks, so I don't see how this works. Something like that. Guys, you are noisy. You are low-level noisy. Who is low-level noisy around here? Who could be nice low-level noise? I just don't know. Okay, right. So, what? I can still hear you. I've got bikes like Jack Rabbit. I can hear things like 50 miles away. Okay. I heard what you're thinking. During the recess, please. We are not going to talk about it in class. I'll just assume you know it. And it's a good benchmark to say that I'm up to date. I know what's going on. So I wanted to not have to teach on Friday, but that we won't be able to avoid it. I want to do the standard audio too much, and I don't think we're going to finish the standard drawing stuff in here. So I will teach on Friday at 8. At 8 is the last day of the semester or the term, so that's fine. But today we have to talk about standard draw, and we actually have to catch up a little bit about standard output. Just before we do, two more pieces of admin. Firstly, you have to listen carefully and not stick out your tongue. If your survey starts with an M or an N or anything up to a Z, you are going to write first at 2 o'clock, Nata D tomorrow. Come at 2 o'clock, we'll be checking student cards. You have to be in the second set of surnames, M to Z, M to Z. Please, do you understand that? What's your surname?
W.
Williams. 2 o'clock. And the rest of you come at 3:30. If your surname starts with A to L, A through L, you come at 3:30 for the practical test. Now, let's stop calling it a practical test. I'll change the website. It's just a regular TUT where there is no collaboration or speaking, and you are graded. But it's not a test. Don't think of it like that. It's a normal TUT. And there'll be 3 questions. You have to work quick, fast, and hard, but it's not going to be overly difficult. The test wasn't too difficult, was it? Did I aim it too high? No, well, you can't tell. I can tell. I aimed it just right. Second thing, we had a first feedback session yesterday afternoon. Who was there? Who was there? Gareth was there. Sebastiano was there. Other Gareth was there. And where's Cornele? and then, okay, how did it go? Was it okay? Wasn't painful? Better than the letters? All that? So, the first week of next term. So this Tuesday before this one. So the 29th. Hang on. Go. Okay. What's your name? Williams. What's your surname? Steele. What's your name? Williams. Williamson.
No, sir.
Just William. Steele. That's amazing. That's amazing. Surname. It's a crack first name, but it's an amazing surname. Why don't your parents call you Ren? Because your parents should have grown up in the 80s. This is famous detective guy kind of guy called Remy. Never mind. Okay, fully up. So first week of next term, the 29th, the 30th, and the 31st. We shall carry on with these study groups as they are now. So Ntobaleng, Gareth, Sebastiano, and Cornelia, who's not here now, and someone else whose name I can't recall. No, we only need 5 of you. You must please remember to come also on the 29th. Okay. Got it, Ntobaleng? Okay, good. Right. If your name appears on this list, and you don't know it, you missed Monday's class, clearly. Because this is not like a name and shame, it's only that these are not people who did badly on the test. I mean, Gareth did okay-ish, didn't you? No, Sebastiana did okay-ish, didn't you? Not a pass, but almost. So it's not only the worst of the worst, but I want to see these people face to face. If your name is on here and you weren't in class, that means your name is not on the following slide either. Well, it's here, but it's not here. So that was yesterday's session. We didn't have a session last night for personal reasons, but there are still slots open here. So after class, if your name is on this first slide, just check for your name and your student number. It's arranged according to student number. So the student numbers go blah, 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 blah. Then, well, if there are too many of you, I don't know what I'm going to do, but please come give me your name at least. Right. Where is Miss or Mrs. Mr. Mhlophe? Come on, you put down your name. It's not in the text. Don't be shy. What's your first name? What? You have to say hello. I can hear her, but I can't hear you speaking again. By the way, you don't. You say yes as if it's not, as if it's say right. Just wait a while, I can figure this out. Look, I'm wasting all this time. Talk to Mr. Mhlophe, but this is important. Mr. Mhlophe, you put down your name for yesterday afternoon and you didn't come. You mustn't do that. That is not right. If you put up your name for, you were right, I apologize, you were right. Your first name is Lindani. I can check it now. Okay. So Lindani, you was coming to put down your name. You're probably going to say you don't know, but that's okay. You kind of have almost an excuse, but the rest of you, if you put down your name for a study group, you must please come. Because the student, the tutors, they also have a life, they're also studying, they're also students, and it's not nice to waste their time. So they've complained in the past that only one person shows up when there are 10 names put down. But since I am at the study groups now, if you do that to me, Lindani, again, I'm gonna do stuff. I haven't decided what, but it'll be something. You can bet on that. Now that's a thread. Okay. Now, that's the one, and that's the only announcement. So let's get back to the real work. We started talking about input and output on Monday. I can't recall what he said. I must have shown you, maybe this, no. This was on Friday when we did something else. I'm so busy, I can't remember week to week. Yes.
I know it's
what now? What is now?
I'm sorry. But is there any chance you can put the project resources on?
Yes, I promise you that's part of my big project before Friday.
Okay.
This class has a few gaps, and that is the biggest probably. Apart from the slide translation, well, that's also big. So let's just quickly recap. I'll have to watch the video, but we did do something on Friday, and we started looking at this input and output stuff. And I told you about Michelangelo. We most talked about the terminal. There's a terminal in Ubuntu and on the Mac. And even Windows has a terminal window where you can do stuff. And it works pretty well, but it's not as nice as the Ubuntu and the Mac terminals. This terminal is really important. It's not just nostalgia. It's not only that in computer science we used to only use the terminal. We didn't have a graphical user interface, and that we somehow believe that everybody should suffer like we suffered when we were young, and that's why you have to learn it. It's also because you can do stuff in the terminal that you simply cannot do in a graphical user interface. It's making noise, I don't like it. Okay. And we'll see some of that today. Really, the terminal is much more powerful than the graphical user interface in some ways. Not for everything, but definitely in some ways. So I'm pretty sure we looked at this. Maybe not. Bottom line is that sometimes we want to read things from the command line, and that is fine, we can do that. There's no issue with that. We've all done this. We did this from the start. And we use system and other print line to write them to the screen or to the terminal, wherever. And this works fine. And if we just say system and other print line, this out is a kind of indication that it goes to something called the standard out. So it's as if each program had 3 pipes. One pipe is called standard out, and that's usually where we send the normal output of the program. One pipe is called standard error, and that's where we send any error output. So if the program misbehaves, we usually write a little message to standard error to tell the user what we got. It's important that we distinguish these pipes, because sometimes somebody wants to see not lots of warnings being sent to standard error. That interferes with the output of the program. And they only want to see the real output. So then they can take standard error, that pipe, and they can pipe it into a separate bucket. So they don't have to watch on the terminal. I'm coming. Yes. Okay, test here, 11 o'clock, so I'll end a little sooner and I have to go a little quicker. Right, so sometimes you want to put standard error, I'm going to speed up, there's no interpretation, so it's fine. Sometimes you want to put standard error into a separate bucket. Actually, you just throw it away, so you only see standard output. And sometimes you want to do the reverse. The program produces a lot of output that is interesting and meaningful, but you only want to see the error messages. Like the compiler, sometimes you want to focus on the error messages, and you only want to see standard error. Oakley dokley, right. So what we've been doing is reading command line arguments and writing to standard output. And what we're now going to learn to do is to read from a different pipe called the standard input, and also use standard audio and standard drawing. And today we'll only do standard input and perhaps a little drawing. So differences between command line arguments and standard input. Big difference is if you specify command line arguments for the program can read those and act on it, but while the program is running, it can't read additional command line arguments. It's not as if the user can go back and add some values to the command line after they pressed enter, after the program has started running. That's where we need standard input, so that the program can do something, perhaps think of a random number, and then ask the user to guess additional input, and then the program can read that additional input, so it's interactive in that sense. And there's a library. The textbook comes with a library that will be on the resource pages also. I know you're referring to the project res, but this is there's a resource page, or you can get it from their website as well. There's a library called standard in and one called standard out, and it has all these routines. So they're almost the same as the ones we used to. They're almost the same as the scanner, in fact. When we use the scanner, we use read int, read double, perhaps. It's not the same as getting things from the command line where we use parse in, parse double. It's pretty clear what it means. And standard out is almost exactly like system.out. Why do they have these libraries? It's just to make it a little easier and clearer that this is what you're doing. You're reading from standard in, you're writing to standard out. Normally, writing professional Java programs, we don't use these libraries. But they are convenient also because in maybe today and maybe on Friday, we're going to learn about StdDraw and standard audio. So they have all these standard libraries, and then things are kind of harmonious. You don't have to learn 50 separate subsystems in Java to be able to use these things. They kind of have a uniform interface. Okie dokie, so let's just see how it works. Instead of going system.out.println or print, I'm just give me a second. Instead of system.out.println or print, I'm just going to go system.out or standard.out.print. And instead of using the scanner the way we set it up, all I'm going to type is standard.readInt. Standard.in.readInt. So to read an integer from the from the terminal, I say standard.in.readInt. That'll send back an integer that's just been typed. And in this case, it will put it in variable x. And instead of saying system.out.print and print line, I'm going to use standard.out.print and standard.out.println. So it's basically the same that we've been doing until now, and you can mix these up. I mean, if I wanted to, I could have system.out.println in this program, and nothing will go wrong. They both do the same thing, and in fact, probably inside, this is exactly what standard.out.println does. I'm not sure, but we'll find out later. But it is nice and neat if you stick to one of these approaches at any one time. So try not to mix them up too much. So this is a little program that reads two numbers. It says, type the first integer, and then it reads it. And then it says, type the second integer, and it reads that. And it calculates their sum, and it displays a little message that says the sum is whatever it is. So this is easy peasy program. We've done this since day one. Here is something that's a little more intricate. This is a program that's also going to read numbers from standard input. It's not going to prompt, so it's not asking type the next number, type the next number. It just reads them. And it adds all of them together, and when there are no more numbers, it will calculate the average and display that. So let's just see what it does. It starts off by saying that sum, which is the double, is 0. Okay, cool. So we start off with 0. And n, which is an integer, which counts how many values I've read, starts off with 0. That's fine. And then it has this construction. It says while standard in dot is empty, not in front. So while not, standard in dot is empty. This is a routine. It's like standard in. It's a function we can call, like math.random, site, all those functions we know, that checks if there are more numbers coming. So if there are more numbers, is empty will be false, because the standard in is not empty. There are more numbers waiting to be processed. So there are numbers, is empty is false, and not is empty is true. It's fine, just close it properly. Because there are people outside making a big noise.
Kies ek skryf en ek het net klaar geskryf en kry dan die klaar.
As jy in die klas nou?
Ja, ek het dan net geskryf.
Ek verstaan, okay, maar neem jy RW114?
Ek het laas uit gekom. So ek wil net vra.
Okay.
Sit so nog net.
Okay. Almal nie. Okay, cool. So, while there are more numbers coming, double X, declare a variable X, double, and read the next double. So grab the next double, send it in, add it to sum and increment n. Because I've just seen another number that needs to be added to the total, and I count how many numbers I've seen. And this keeps on going until that while condition is false. So it'll be false if is empty is true. There are no more numbers. Standard in is now empty. So not of that true will be false. And while false, we'll stop the while loop and we'll come down here and we'll we'll print line the sum divided by n. So the total divided by how many numbers there are. Yes. You understand the while loop? That's excellent. I'm just repeating some Gigi thing here. Yes.
So the standard is it? I don't understand how that condition is like.
How it works. Okay. So standard in on empty will send back one of two values. It's Boolean, it will send back true or false. And if there are more numbers, that means standard in that pipe is not empty. There are more numbers in the pipe waiting to be processed. These people are writing a test here, but they're so excited about bank writing. I know you're writing a test.
No, I'm not.
Are you writing my class?
Yes.
Oh, wow. At least you can. I don't want to lock them out. It's just like I don't want everyone coming in. Yes. Are you in this talk? Okay. What's your name? Lisa. Okay. Like Lisa was Paul. Okay.
Should it be started because we need to divide it
Okay. Let's push that onto a stack and come back to it in a second. I just want to finish explaining is empty. So there's a pipe of numbers called 7 is empty asks, is this pipe empty? If there are more numbers waiting, is empty will send back to false because it's not empty. Is it empty? No, false. And so the while is saying while it's not empty, while not is empty, keep on reading numbers until is empty sends back to true, then the while loop will stop. And is that a little clearer? I can repeat it again, but at least at the moment I can't think of how to add to it. Okay, let's pop your question from the stack. Should n start at 1? See, this is all about your relative honesty. This is about being honest with yourself and your classmates and your lecturers about what you're doing. So, before you get to the while loop, how many numbers have you read? Lisa, if that's even your real name. How many numbers? What? 0. So why do you want to put in 1?
because we need to divide it.
Oh, Lisa, that's brilliant. So Lisa is saying that there are no numbers in the pipe ever, and we keep n 0, and then the pipe is empty to start with. We're not going to add anything in the while. We're going to jump over the while, and then get to this and say, okay, so the average is sum, which is 0.0, divided by n, which is 0. Oh, division by 0. Big mistake. Is that what you were thinking, Lisa?
No.
No, but yes.
I was thinking that's also it. I was just thinking that if like you go through the mile and then
Yeah.
divide it by 1 day, then that number is.
One fewer.
Yeah.
Just go to that. Okay, right here. So, no, I think that is correct. It's not going to be divided by 1 less. I count how many numbers I need. I start with 0. Every time I get a number, I make n1 board, and then I'll have 5 numbers. And average is always total divided by a number of numbers. Total divided by 5. If you are confused by statistics, where we sometimes divide by 4, sometimes in statistics we divide by 1 less than the number. Do you know what I'm talking about? Are you doing statistics? Well, let me prepare you. Sometimes in statistics, when you want to calculate the average for 100 people, you take all their marks and you add it up, and then you divide by 99 instead of 100. And that is because you have an enormous population of students, but you're only averaging over 100 of them. So you're taking a sample from the population. And in that case, it's sometimes necessary to fudge the average a little bit. Statisticians are always lying to you. And they're always making little lies somewhere, and they can't help themselves. They're like pathological liars. They have to introduce a lie somewhere. So they divide by n minus 1. But let's forget about that entirely. Other minus, we are honest people. So we count the number of numbers that we're adding up, and we divide by that number. But we still did point out a serious problem here, and that is that there are no numbers in the pipe to start with. Dividing by n will be dividing by 0. And then we'll get a division by 0 problem error. How are we going to fix this, Lisa? Divide by n plus 1. Is that your solution for anything? Clearly, we can't divide by n minus 1, like I do in statistics. Because then, if there's one number in the cube, and I'm going to divide by n minus 1, I'm dividing by 0 again. So now I've got a second situation where I am get a division by 0. So one solution is to simply put an if around here. To say, if any 0, don't print the average, print there were no numbers, else print the average. So that's one way we can protect this program, make it more robust. Okay, so yes, Gareth. Now that I have a name, I will use it.
Why is there not in front of this guy?
Okay, let's pretend the dot was not there. So no not. Then it says while standard input is empty, read the number. That doesn't make sense. You can't read from an empty pipe. That's why it's saying while it's not empty, while the tank, the pipe is not empty, read the next number and add it to the sum, add it to it. Yes. You told me already about where we have it. Yes? Robin. Robin. Oh, yeah. Yes. Robert. Standard in and scanner. So scanner is a much lower level. And that's how Java really works. And if you look inside standard in, you'll see that it's actually using the scanner. The standard in is just a nice library like math, like other libraries that's provided by the people who made this textbook. And it has all these nice routines that we can use without worrying too much. So if you wanted to use the scanner, you have to put that magic line at the top of the program, didn't you? And you have to put import Java util scanner at the top, which I can't even remember. I have to look it up every single time. But standard in, you can just use. You can just start using it. Look, there's no scanner anywhere close to it. So you can just start using standard in, and it works perfectly fine and in the same way as the scanner. Okie dokie, let's just finish at least a small part. So I'm now going to do a little trick. I'm going to take my random sequence program, which we saw. Did we see it? I will show it over here. Right. So random sequence, it takes a command like RW114, and it just prints n random numbers. It just prints numbers like these. So if I set random sequence 4, it would print 4 random numbers. That's what random, 4 times. Now, I'm going to, instead of displaying these numbers on the screen, like it would if I type this, I'm going to put them into a file. So I'm going to take that pipe, I'm going to take the standard output pipe. Let me show on this side again, I'm going to take this pipe that my random sequence program writes to, and I'm going to put it into a file. I'm going to say at the prompt, Java random sequence, let's say 1000, and I'm going to put that into data, well, I wanted to say txt, but it says text there. And that's going to not write to the screen. It's not going to write anything on the screen. Just put all the numbers in the file called data.txt. And I will prove that to you right now. Let's go here and say Java random sequence 4. Okay, there they are. And now I'm going to put them in a file, let's call it txt. nothing appears on the screen. And if I look inside data.txt, I have 4 random numbers. So I can take these pipes and I can place them, point them towards other places. So in this case, I said greater than, and it takes the standard output of this command, whatever it is. It's writing to the standard output file, this pipe here, and I'm redirecting it to this file. So everything in standard output goes into this file. This is called redirection, redirecting standard output. Yes, you told me your name as well, but I will learn your name soon. Yes. Say it again. Olivia. Oh, is that why you're wearing an olive dress? You always wear that dress. I didn't need you already wear that. Yes, Olivia. Yes. Yes. Yes, they'll be, every time I run it, it'll be different. Well, let's run it a few times on the screen. See, every time I run it, the numbers are different. Well, if I do this now, I'm taking the standard output of this command and putting it into data.txt, txt. But it's not going to be these 4 numbers. It's going to be 4 new numbers. I'm going to run the command, and whenever it says system.out with print line, it's going to not go to standard out on the screen. It's going to go into data.txt. So it's new numbers that go into data.txt. I can prove that to you. Those previous 4 numbers start with 0.94, and data.txt starts with 0.48. Okay. Now, next exciting thing, we're building up to a big climax. I'm going to take data and put it into a pipe. I'm going to put it into a standard input pipe and then send it to a Java program like average. Remember, average ran a lot of double numbers while not standard is empty. It reads a lot of doubles and it calculates their average. And it reads them from a standard input. So, I forgot to mention that. When I run average, it's waiting for me to type in the double numbers. So I'm going to type in a few, 3.4, let's say 5.6. No, that's not 3.4. Fingers in the wrong position. Okay, it's not doing anything. 1.0. Still not doing anything, and that's because the pipe is not empty. Java doesn't know if I want to type more numbers. So I have to kind of send it a signal. And the way to signal it in Ubuntu and on the Mac is to type Control-D. Hold down Control, type a D. If you're on Windows, you type Control-Z, Control-Z. But I'm going to type Control-D now. Control-D. And that's how I signal to Java, to the whole system, that the pipe is empty. It's the end of the pipe, and it responds by printing the average of those 5 numbers. And now I'm going to do this amazing trick. So, just one more thing. I can take data.txt and put it into the standard input pipe, and then send it to average. So I can take all the numbers in data, and I can send it to Java.average as its standard input by writing a smaller than sign. On the last slide, I wrote a bigger than sign, and that tells Java standard output goes to this file. Now I'm going to write a smaller than file sign, and smaller than means standard input. The standard input pipe comes from this file. So I'm taking data.txt and sending it to the standard input pipe of Java.average. So I'm going to do that now. Let's just see. Data.txt, and I'm going to say Java. Do that again. I'm going to say Java average, So drag the average, but read your standard input from this file. And it's calculated that the average of those four numbers is 0.642. I can do both at the same time. I can say, read your standard input pipe from data.txt, and this is going to write one number, the average, to the standard output. And I don't want that number to appear on the screen. I want it to go to a file. So I'm going to say, and write your standard output to aver.txt. So average is going to read the standard input from data.txt, which is still those four numbers. They haven't changed, Olivia. So I haven't touched that file. They're random, but they are still 0.48, all that. So data.txt contains those files, and that's the average. I know that because I just ran that command. And now I'm setting that output to this text file, aver.txt. So let's see what happens. I expect nothing to appear on the screen. Phew, okay, that worked. Data should still contain those numbers at the top. Okay, that seems fine. So data.txt still contains those four same numbers. And average.txt, oh, man, sorry, okay. Average contains the average, which is what I saw over here, over there. But instead of displaying it on the screen, I asked Java to actually write it to a file. I asked Java to take its standard output pipe and put it in a file. Yes. Say your name again. Oh, no. Hoe je het? Goeie vraag. Ah. Het maakt nie saak nie. In hierdie geval, only in this case the order doesn't matter. Some cases it does matter. These people are disturbing me. I'm almost done. Now, triple bundles, triple thread. I'm going to connect, I'm going to run random sequence, and it's writing to standard output. I'm going to take the standard output pipe and connect that to the standard input pipe of average. So instead of writing standard output to a file, data.txt, and connecting data.txt to the input for average, I'm going to connect them directly. And I'm going to use a little bar like this. A little bar character. So that says, run this program, take its standard output, which will be a sequence of random numbers, and pipe it as a standard input to average. And remember, average reads from the standard input. It reads doubles over and over and over, that's empty, and then it puts the average of those numbers. So let's see if this works. A million, okay, a million, I can do this. Java, then 1 million numbers. Okay, you don't even know that joke. Okay, no. Okay. What's the average going to be, Olivia? Yes. What? You said the answer quite softly. I couldn't hear that. Average going to be 0. Daniel? What? South is biggest. What kind of average? Yes. What will the average be? Of a million random numbers. I'm not telling you the numbers. I'd guess 0.5. In fact, no, I'd guess 0.499. Just because. Why? Yes, divide by, I say 4.999. Okay, so 0 is a possibility, but 1 isn't. Just slight pull to the 0 side. Okay, right, let's see what happens. Ooh, it's taking a while. I wonder what they're writing. Wat skryf julle? Wat skryf julle? Toegepaste wiskunde wat? 1, 2, 4, 4. Is it $3? Just kidding. Ek kan volgende niks hoor hier. Ons praat al die tyd. I can already say them. I legitimately finish. We can. Oh, whoa. Why is it more than 0.5? Random fluctuations. That's why, man. It's the crystals, man. It's the crystals, man. Let's just play around with this a little bit. Above, below, above. Below. So who knows? Maybe I'm wrong about that. Pull to the 0 side. So I can connect my programs up like this. In fact, I can connect many programs. I don't only have to connect 2. I can take the standard output that I've now received on this, and I can connect it to the standard input of the next program, and the next program, and the next program. So if you're a command line guru, you can write things like the following. What shall we do? Let's take a few random numbers, like 5, okay? And I'm going to connect that to a program called sort. So the output of random sequence, 5 random numbers, are going to be the input for sort. And sort is going to sort those random numbers. So they'll be different, but they'll be sorted. Yes. Have we just Java program I just wrote? Sort is a Unix program. It's talking to this system. So I'm going to sort it. Okay, and they're different. If I run it again, they'll be different because I'm making random numbers, but they are definitely sorted from small to big to large. Okay, and next, I'm going to take this output and I'm going to run it through a little program called, what shall we? Let's use cut. There's a program called cut. Cut, and I have to give it some parameters, some command line arguments. I'm going to say cut. I only want the third and fourth digit, so I'm going to say C4 and 5. Okay, so this gives me the third and fourth, I think, digits after the decimal point. And now I'm going to sort this again. And then I'm going to count the number of characters and lines. Let's use that. Okay, so what am I doing? I'm making random numbers, generating random numbers, passing that output to sort. Sort gives me a sorted list of the random numbers. I'm piping that to cut, which cuts off a column, 2 columns. I'm sending that to sort again. So that's sorting those numbers up there. And then I'm sending it to a program called WC, word count. You guys stop it. You're not going to sit next to each other again. You are going to sit there where, I don't know what's his name, Randy is sitting. And you're going to sit there where Gustav is sitting. Okay. And that's the end of standard input. So Friday we have to do standard output and standard audio. And that's a big pity because I really want to do audio, but I'll update the website. And remember, there's a study group today, people, today.